Hi, everyone. Let's say that I go on Maury and I find that I have two college-age kids. Wow. So the first thing I do is send them off to statistics class because I do that. Maybe these are my kids or thing one and thing two from Dr. Seuss. I don't know. But let's say that they take these two statistics classes and they take different tests, both out of 100 points. So I have a shiny new iPhone I'm going to give to my kid who does relatively better on their exam. Now, let's say that both of my kids tell me that they scored 70 points on their first statistics exam. Well, in which of these two classes would 70 points be more impressive? Which kid would be more deserving of the new iPhone? And I don't care if you prefer Android. Let's say they want the iPhone. Okay, so let's say that for kid one, the mean and standard deviation for class one, which kid one is in, had a test mean, mu sub 1, of 55 points and a standard deviation for test 1 of 5 points. In class 2, where kid 2 is in, let's say that the mean, mu sub 2, was 60 points and the standard deviation, sigma sub 2, was 10 points. So which kid should get the iPhone? Let's assume that the iPhone is preferable, right? Is a desired item. Let's ask ourselves, which kid deserves the iPhone? In which class is a score of 70 points more impressive? I'll give you 15 seconds to think about this. You can also compute the z-score. Okay, so if you work out the z-score, kid 1 in class 1, if kid 1 got 70 points in that class, we take 70 minus that class mean of 55. So kid 1 scored 15 points above the mean. That's pretty impressive. Dividing by 5. So the z-score was 3. Now, if the kid scores 3 standard deviations above the mean, how well did the kid do relative to the class overall? That kid did extremely well relative to the class overall. This kid did unusually well. 3 standard deviations above the mean, that's an unusually high score. Now in class 2, well, kid 2 did beat the mean, but only by 10 points. 70 minus 60, the class mean for class 2, that deviation was 10 points, but we divide by 10 points. The scores were spread out. So that kid's z-score was only 1, which was 1 standard deviation above the mean. Granted, kid 2 did beat their mean in class 2, but not as impressively as kid 1 did in class 1. So a score of 70 points is more impressive in class 1. In fact, it's unusually high in that class. Kid 1 deserves the new iPhone. And kid 2 can settle for something less. All right. Now, if we assume normality in both classes, we can draw the following pictures. Okay, and then if you're more of a visual person, see, this might be more for the algebra and arithmetic people, but if you're more of a visual person, imagine this. Class 1 had a mean of 55 points and a standard deviation of 5 points. Remember, one interpretation for standard deviation is as the horizontal distance from the mean line to either inflection point, where the graph changes concavity. Again, you don't have to know that, but it's a nice thing to know, all right? But notice here that the mean is lower, 55 points, and the scores are more tightly clustered about the mean. The standard deviation was only 5 points. I'll omit the unit here, all right? So the 70 points here was much more impressive. Whereas in class 2, the mean was higher. The mean was at 60 points, and the scores were more spread out. Sigma sub 2 was 10 points. So again, even though kid 2 did beat the mean, the 70 points here wasn't as impressive. One way to look at it is that a higher proportion of students beat kid 2 in class 2 than the proportion of students in class 1 who beat kid 1. In fact, it's quite possible that kid 1 got the highest score. It's unlikely kid 2 did. Okay, next time, more ways of looking at relative position in a data set.